Hello class, today we're doing lesson number 7 of chapter 9 and we're going to learn how to divide polynomials, and we have here a cartoon. Uh, Numbers are beautiful. I like 2's the best. They're sort of gentle. 3's and 5's are mean, but a 4 is always pleasant. I like 7's and 8's. I like 7's and 8's too, but 9's always scare me. 10's are great. Have you done those division problems for tomorrow? Nothing spoils numbers faster than a lot of arithmetic. And yes, arithmetic in itself is a long, arduous process. It's something that you do over and over and over, and sometimes you say, why am I doing this? Well, one of the things about arithmetic is that it teaches us not just the math and the concept, but you also develop a good feeling and understanding of these numbers, and you almost memorize numbers in terms of what you multiply. And 7 times 7, you don't actually multiply in your head. You just know that it's 49. And 49 divided by 7, well, you might refer to the multiplication. You might reference that, or you just might just remember that again through memory. But when we start dealing with algebra, there's no memory involved here. It's really understanding exactly what it is you're doing, and you're gonna learn that in this particular lesson. So let's start reading at the top of page 430. It says, most people learn to divide one number into another without knowing why the method works. For example, to divide 7 into 2,205, we're taught to write, and we have 7 here, and then we have the division bracket here, or the long division bar, or the long division symbol. I don't know exactly the technical name, but we understand long division. So we have 7 being divided into 2,205, and see all the work that's being done, and the answer is 315 at the top. Now, as you may recall, this method has its basis has as its basis repeated subtraction. Okay, and here is the same calculation written out more completely. Okay, if we were to multiply, for instance, 7 times 315 below, you would notice that you're basically going to get the same numbers that you're dividing underneath here. Okay, so you can sort of just see the connection between division and multiplication. I think we've established that quite a bit. I talk of them as being cousins and maybe even siblings in terms of math, and we can see where they really match up here. So let's go over to the top of page 431. In the first step, we subtracted 307s from 2,005 to leave 105. So we see that over here. In the next step, we subtract 10 more 7s from 105, and that leaves 35. And in the last step, we subtract 5 7s from 35, and that left us 0. So we can see, because we have subtracted 300 plus 100 plus 5 7s altogether, okay, the answer is 315. We subtracted 315 7s. So if you go back to our our original, well, up at the top, we were looking at 21, and then we were looking at 7, and then we're looking at 35, but there are places there, and those places are sort of hidden. But that's exactly what you were doing. If you go down below, it sort of gives you a little deeper look into what you were actually doing. We did 7 times 3, even though it was 21, it was actually 2,100. Okay? Why? Because first off, that 3 isn't just a 3 in our answer, is it? It's 300. Okay? But we didn't really put all those zeros in there because it just makes it maybe a little bit more confusing. But now when you start opening it up, you start seeing that we did 2,100, then we did 70, and then we did 35. Now, one way of interpreting what we have done is in terms of a rectangle. And this is very important. Take a look at the rectangle on the side over here. It says, given that one dimension is 7 and that the area is 2,205, we have found that the other dimension is 315. So if we were doing area, we know we multiply the two sides and we'll get the area of a rectangle. So we take the length times the width, and that gives us the area. So that's pretty much what we do with with multiplication. To check this, we can simply multiply to find 315 times 7 is 2,205. But if we were missing this element, we would divide 7 into 2,205 to get that 315, which is what we're discussing here. Now, compare this check with the division problem written out in full, and you'll see that one is the same as the other in reverse. Now, this is where we're going to start heading into algebra, because now it's not just going to be numbers that we remember. It's not just going to be 7 times 3 and 7 times 5. Now we're going to be dealing with the x's and the x squareds. So we're really going to have to start applying the concept of dividing here. Now, a procedure similar to the one we used to divide one number into another can be used to divide one polynomial into another. To see how it works, we will begin with a multiplication problem. What is x plus 2 multiplied by 3x plus 5? Finding it the long way and illustrating the procedure with the diagram we get, and we did here, we've done this in the previous lessons. Look at the diagram here with the box, where we have x and 2 at the top and 3x and 5 on the side, and we would multiply 3x times x and we get 3x squared. 3x times 2 we get 6x. Then we drop down, 5 times x is 5x, and 5 times 2 is 10. So now we just add these all together, and you can see that's basically what we're doing over here on the left. Okay? Now I like these boxes because the boxes sort of neatly put things into places, and we understand that if you just add everything together in the box, we would end up with the product of these two binomials, let's call them. All right? So now we will consider this problem in reverse. Okay, so we understand that if we multiplied these, we would get what's in the box, and we could simply add it, and the answer would have been 3x squared plus 11x, because we're going to add the 5x and the 6x, plus 10. Now, we will consider the problem in reverse. What is 3x squared plus 11x plus 10 divided by x plus 2? Now, this is going to require, and we're going to start working here on our chart here. I'm going to put a box up on the screen so we can go ahead and and work together with this. Okay, so we have our box up here, and we're going to go ahead and follow exactly the steps that they do so that we can learn how to divide 3x squared plus 11x plus 10 divide that by x plus 2. Now, again, thinking in terms of a rectangle, the problem is to find the other dimension of a rectangle if its area is 3x squared plus 11x plus 10. So we understand that we can put inside of this diagram. Similar, if we just look at the very top of our page, we had 2,205. That's inside the box. That's the answer of 7 times something, which we knew was 315. So the area, the area that we have is 3x squared plus 11x plus 10. Okay, let me just write that in there. All right, so if we were looking at this box, okay, and we would say that the area, and though it's not area, but we're just going to use this term loosely right now, it could be the area. Let's see, it's 3x squared plus, let's see, 11x plus 10. Okay, so, and we have the other dimension of x plus 2. So one of the sides, let's just say one side, is going to be equal to, let me just call it one side, and that'll be x plus 2, right? So we put x plus 2. So we know that we can simply put x and 2 here. Okay, we've already learned this. All right, we're just sort of doing this a little in reverse, because what we would normally do is put these two together, and then put the other part of another binomial, and then we just do our math, multiply, and we would find the area. But now we know the area, we just need to find out what's going on over here. What's this dimension? And in doing so, what we need to do is put the answer inside of the box, right? So that's what we're going to do. So we're going to put 3x squared here. Okay? Now, for this to be 3x squared, we know that we have x here. This has to be 3x. Why? Well, 3x times x squared, x is going to be 3x squared, right? So we know that, okay? It's basically you're dividing x into 3x squared. But again, just think of what do you multiply? That's what you do. You say, well, what's 21 divided by 7? Well, what do I multiply by 7 to get 21? Oh, the answer is 3. Well, the same thing here. 3x squared divided by x, well, that would be, what do I multiply by x to get 3x squared? Well, that would be 3x. So that's why we have that answer there. Now, on this side, we already know that 2 is one of the dimension here. So we would multiply this to get this. So we have to multiply now to get this number. Okay? We say, well, what is 2 times 3x? Now, the reason we're doing this is because this number here, 11x, or this term, is always going to be in the case where we're dealing with these polynomials to second, well, let's call them quadratic. Quadratic equations would actually be, but this is a quadratic expression, let's just say, because it has a square here. Okay, so we're dealing with an x squared, an x, and then just this number here. We've already understood this form. We would always add these two together. Okay, so we know that whatever we add here is going to have to equal to 11x. And if this is 3x squared, which it has to be 3x squared for us to have an x here. So you would know that. So this is going to have to be 6x because you have to multiply 2 times 3x. So you're forcing yourself into giving yourself the answer. You're forcing yourself to say, well, in this part of this area, we have 3x squared and we have 6x. Now, for this to be 6x, then this has to be 5x. And how do I know that? Well, because I have to add these two and they have to equal 11x. So you see how the first thing we did was we had to find out what this was. The second thing we had to do was multiply to find out what this was. And by knowing this, then we simply had to subtract it from our term here, 11x, and that's how we found the third one, okay? And now knowing this, what do I know? Well, I have to multiply something by x to get 5x, so the answer would be 5. Would it not be? Yes, 5 times x is 5x. And now I'm simply left with 5 times 2, which is 10, which is our third term over here. So it works. So the answer to our problem is then 3x plus 5 is the answer to this to our equation, or I'm sorry, to our expression 3x squared plus 11x plus 10 divided by x plus 2. So our answer is the other side. Okay, let's call this the second side. Let's put a first here, and this is our second side. And our second side is equal to 3x plus 5. Okay, so again, you may have had a problem in the past where you would have had x plus 2 and 3x plus 5. And you say, well, what does that equal to? Well, it's equal to 3x squared plus 11x plus 10 because we would have followed the same blocks and we would have filled in our information, add them up, and this would have been the answer. Now we figured out a method, the first method, and I'm sorry, I should have put the fourth one here. This was the fourth element. Okay, so the first element was to determine here what do we divide, or what do we multiply x by to get 3x squared. So we got 3x, so that was the first one, okay, and that's part of the answer. The second thing we did was we multiplied over here the 2 times 3x, because we already know this is 3x, and we got 6x. Knowing this is 6x, we have to understand that for these two to equal 11x, this has to be 5x. So that was our third bit of information we found. It was an unknown. We had to figure it out. But knowing this is 5x, what do you multiply by x to get 5x? That's 5, and we actually answered it. And by simply doing our last step here, multiplying 5 times 2, we got 10, and we're able to check, yes, that is our answer. So our answer was 3x plus 5. Let's turn over to page 432, and let's read. This means that the area of the rectangle at the upper right must be 3x times 2, which is equal to 6x. Okay, that's what we did in our next part. That we already did these steps. So we were able to see here that we ended up with 5x as the answer. We see that the area of the rest of the figure is 5x plus 10, writing 5x as the area of the rectangle in the lower left. Now, I could have also said just at the very beginning, I could have actually just put this 10 in here, okay? Because again, we know that this term, okay, 3x squared, is always going to be here. And in these particular cases, that's going to be here. And we know that the 10, positive 10, let me say, okay, let's not forget that, is going to be here. And that's very important, that it's positive. If it's negative, then we're going to play a little game with the negatives, because this gets a little bit tricky when we start playing around with negatives. So we would have had 10 here, and we could have figured that out from the very beginning, that 2 times 5 is equal to 10, okay? But I wanted to take you through this process so you can see how it all connects. Okay, so we could have easily have just gotten this answer here, and we could have just figured out that the 5 times 2 is equal to 10. Okay, so writing 5x as the area of the rectangle in the lower left, we see that the other dimension must be 5. Okay, that's the way we approached it. So the area of the rectangle on the lower right is 10. So we've gotten that. Okay, all of the area has now been accounted for. So the other dimension of the rectangle is 3x plus 5, which is our answer. Now, here is the procedure written as a long division problem. It is broken into steps to make what is being done easier to see. Okay, so now we're going to do this in a different manner. Let me just take away our board here. Okay, so the first thing that they did was they wrote this as we would do long division. Okay, so we have x plus 2 divided by a little curve there. We've got this long bar because we have 3x squared plus 11x plus 10. Now this could be a little bit intimidating when we see this, because say, well, how do we even begin to solve this? Well, let's think of what we did before. Okay, let's take our first step here. And we say, well, what do I get when I divide x into 3x squared, or what do I multiply, okay, x by to get 3x squared? And we know that answer to be 3x, right? So let's write 3x up here. Okay, so now I multiply 3x times x, and we get 3x squared. But what happens when I multiply 3x times 2? Well, I get 6x, okay? So now we have 6x. So what would we do if we were dividing? Oh, we would subtract. So 3x squared minus 3x squared is 0. So I've got nothing there. Then I have positive 11x minus positive 6x, and that would give me 5x, okay? So now I'm back to dividing, all right? Oh, I'm sorry, 5x, and I bring down the 10. Now I'm bringing down the 10, as we would bring down the next number as we're dividing. So we bring it down, and we have plus 10, okay? Now, what do we do here is, well, we're going to say, what number do I get when I divide x into 5x? And we already know that. It's going to be positive 5. So it's plus 5, right? X times 5 times x is going to give me 5x. And 5 times positive 2 is going to give me 10, positive 10. And now when I subtract these, I get 0. Okay? So, what was my answer? Well, my answer was 3x plus 5, the same that we would have done, well, we did when we did the box. Now, I really like using the boxes because it really helps you to see, in a sense, the smaller increments of what you're multiplying and then simply adding together. But this is long division, and you're going to be challenged to do it both ways, okay? We have a couple of examples here. If we look at example number 1, we have here divide x cubed plus 2x squared minus 8x plus 35 by x plus 5. Now that's even much more complicated, but we can see here that they simply did the same thing. They divided x cubed by x. Okay, so maybe we should do it up here on the board because we only did one. So let's do another example. We have x plus 5, and we have x cubed plus 2x squared minus 8x plus 35. Okay. And we ask ourselves, well, let's start with the x. See, here's the thing, is you can't just look at this all together. Think of the x. The x has to work first. If the x doesn't work, nothing's going to work. And we'll let everything else take care of itself. So the first thing we do is we look at this x and we say x divided into x cubed. Well, that has to be x squared, right? X squared times x is going to give me x cubed. So now I multiply this times everything here. So what do I get? I have x cubed, and then I have 5 times, positive 5 times x squared would be plus 5x squared. Okay? So now we subtract. We have 0 here. Now I'm going to get a negative. Negative 3x squared. Okay? And we're going to bring down the negative 8x. All right? And now we're going to ask ourselves, what is negative 3x squared divided by x? Well, we have a positive and we have a negative. So obviously our answer is going to have to be negative, right? Because whatever I multiply by x, the positive x, for this to be negative, this has to be negative. And what would that be? Well, it would be 3x, right? 3x, negative 3x times x is going to give me negative 3x squared. So let's go ahead and do our math. Multiply these two. We get negative 3x squared. And then again, be very, very, very careful here. Negative 3x times positive 5. Well, that's going to give me negative 15x. Okay. Now this is where our math is going to get a little tricky. And actually my board is getting tricky. Won't let me make a 5. Okay. Alright, so we're going to have to be champions of subtraction here because obviously negative x squared minus negative x squared is 0, right? Always got to remember, I have a negative, I'm subtracting a negative. It's the same thing. I'm subtracting what I have. But what's going to happen here? Well, remember when you subtract a negative, well, we did it here. We had a negative, and you subtract a negative, it's like adding a positive, okay? And that's what's happening here. You have negative 8 minus 15, or negative 8x minus 15x. It's like saying negative 8x plus positive 15, and the answer would be 7x. And again, you have to be champions of addition and subtraction and multiplication and division, particularly with negative numbers. This is where your math is going to have its greatest challenge, understanding this element here. We learned it early. It seems simple, but this is where we have our greatest pitfalls. Handling negatives, handling them properly, subtracting a negative, understanding that when you subtract a negative, it's like adding a positive. Understanding it's sort of like the inverse operation. If you're adding a negative, all right, it's like subtracting a positive. If you're subtracting a negative, it's like adding a positive. I mean, you can sit there and play around with these things. It's like the polarity. It's positives and negatives. So we have our answer here is 7x, and we're going to bring down our 35, positive 35, and the question is x divided into 7x. Well, that's positive 7, and 7 times x is 7x. 7 times positive 5, again, is positive 35. And we have a remainder of 0. Okay, so our answer here is, well, we take x cubed plus 2x squared minus 8x plus 35 divided by x plus 5. The answer is x squared minus 3x plus 7. And if you're doing this and you're understanding just the simple little incremental steps, you're really starting to learn algebra here. And what's really neat is that if you look back at our original question and you say, wow, how do I divide this crazy looking expression divided by this other semi crazy looking expression, and you get this answer. This is now the beauty of algebra. You're not going to be able to just look at these expressions and say, oh, let me see, that's x squared minus 3x plus 7. It's not going to happen. I mean, you can get there, and if you do get there, well, I challenge you to really to challenge yourself in further, and who knows what you could do. Okay, you could probably be a science or at least a mathematical genius if you can just do this in your head. And I'm sure there's some that can, but the fact is we're doing this and we're getting these answers and we're able to say, hey, here's my answer to a very complex problem, but I simply took it step by step by applying the things that I already know. So that's the, oh, I'm sorry, there's one more example here. And you could see that they have x cubed. Let's go ahead and pop this one up on the board as well. Okay, on this problem we are dividing x to the third minus 64 by x minus 4. Now, one thing that's happening here is that we're missing things that we're going to need when we divide. And you'll notice that we see neither an x squared term nor we see an x term. Okay, now before dividing it, it helps to insert these missing terms with 0 coefficients so that we'll be able to keep the like terms lined up. Now, when we use a 0 as a coefficient, the answer is always going to be 0. So we're adding something here that we're really not changing the value of the expression because we're just adding 0. But we need them so that we can keep everything lined up. So let's go ahead and do this and follow their example. So we have x minus 4. Now we have this big big long. Now we know we have x cubed because that was the number that you get, or that's part of this expression, and it's supposed to be minus 64, but let's go ahead and say plus 0x squared, and then we're going to also say plus 0x, and now we're going to subtract the 64. Okay, now again, let's just go back and say, why do we do this? Oof, that line is not very straight. Well, the reason we did this is because we need these when we start doing our math, and we're dividing, and we're going to have to multiply, and we're going to end up with a problem because we're going to end up with an x squared, and we're going to say, well, what do we do with that? Well, we have 0x squared, and 0 times x squared, regardless of the value of 0, is always going to be 0. So this is sort of like a phantom. These are phantom terms, okay? I could say plus 0, plus 0, plus 0, plus 0 all I want here, and it doesn't change it. But we have a purpose in doing it here because we'll be able to divide now. So let's go ahead and do our division. X into x cubed would be x squared, right? Because x squared times x is going to be x cubed. Now you're going to see here that I'm going to multiply x squared times negative 4, and I have negative 4x squared. Now, going back to what we said, what would we have had if we would not have placed these? We would have had 64 here, and that would have been a big problem because you say, well, how do I subtract 4x squared or negative 4x squared from 64? Negative 64 would have been a problem. But now we can actually do this math. So what's 0 minus 4x squared? Remember, you're subtracting a negative. It's like adding a positive. So it would be 0 plus 4x squared, which is 4x squared. Okay. And now we're going to bring down 0x. Okay. Now you might say, well, okay, what is x into 4x squared. Well, remember, we've got the 4. It's positive. Everything's positive, so we know this is going to be positive. So x into 4x squared, we will multiply 4x times x would be 4x squared, right? And it might be a challenge at first just to get comfortable with these things, but over time you'll get used to it. Now we have positive 4x and negative 4. That's going to be multiplied and give us negative 16x. Okay, now we're going to subtract again a negative. So we have 0 minus negative 16, which is like saying plus positive 16, and that gives me 16x. Now I bring down my negative 64, and now I can divide x into 16x, and that would be positive 16. So positive 16 times x would be 16x. And positive 16 times negative 4 is going to give me negative 64. And as you can see, we have 0 as a remainder. We should have 0 as a remainder. If we don't, then we may not have done it properly. Okay, I mean, it's not to say that every answer is always going to give you this, but in the case of what we're learning, you will. Your remainder is not. It's always going to be 0. Let's say when you get into more advanced elements of math, then you're going to see what you do with these things. So, because it's not always going to be a perfect number. So let's or a perfect expression as this. So we know that x minus 4 times x squared plus 4x plus 16 is equal to x cubed minus 64, because again, we just put these in here. We don't have to say 0x squared plus 0x. So that is the answer to number 2. So that is the end of lesson number 7.